Swayam Prabha. Digital India. Educated India.
Dear students, I welcome you for this second class on ground improvement, which is the NPTEL course. As I just mentioned earlier, we should be able to understand the need for ground improvement, different types of problematic soils, and also the emerging trends in the ground improvement. Just to recapitulate what we discussed, this use of ground improvement techniques is very essential, because there is lot of growth in infrastructure and we find it very difficult to have suitable sites for construction. When you have these sort of problems, it is always difficult to handle soils. The soils are different varieties of soils we have, and we try to say that they are all problematic soils or problem soils, and soils can be collapsible. Some soils are liquefiable, some soils are expansive and some soils have a tendency for shrinkage. You have some areas where you have marshy deposits and also soft soils and karst deposits. These collapsible soils are nothing but the soils which have a tendency to collapse upon loading. Many of the reasons, such as the stable or unstable metastructure or capillary stresses, nullification, are some of the reasons for this collapsible nature of the soil. Suppose the soil is partly saturated, and when it comes in contact with water, the moment there is a contact with water, all the capillary stresses are destroyed, and because of this there is a volume change. It is in fact a reduction in volume, and that leads to collapse. These liquefiable soils are most of the times they occur in they are essentially sandy soils, which have a tendency for liquefaction, means they behave like a liquid under the influence of impact loading and like an earthquake. You can see that the earthquake, say for example, this can be before an earthquake occurs, and then when during the earthquake event, which is about 30 seconds to 1 minute, there is a particle rearrangement, and the foundation that you have at the top could sink in. In fact, we can call it a quicksand condition also, which is nothing but static liquefaction, means the soil behaves like a liquid when the effective stress is 0. When the effective stress is 0, the soil loses all its strength and behaves like a liquid. So, these two soils, of course, collapsible soils and liquefiable soils, are problematic, because it is very difficult to have foundations on these deposits. Same is the case with waste materials like municipal solid waste or any of the waste, because in soil mechanics it is possible to understand the consolidation behavior, for example, in terms of primary consolidation and secondary consolidation and all that. But in waste materials you have a lot of biodegradable material, and it becomes very difficult to understand how these materials behave with time. This is a difficult challenge. You have another type, what is called expansive soils, which I can show you the figure here, like I think I am just covering that. So, you can see that these expansive soils are also quite common in many of the areas, where particularly in Deccan Plateau and in some parts of Andhra Pradesh, where the soils have a tendency to swell, means they take lot of water with, and then when you remove all the water, they go to a minimum volume. Like liquid limit is a volume, what is the highest water content in the range of about 100%, and the shrinkage limit could be as low as 10%. So, this extreme range of water contents in the case of expansive soils causes significant expansion, also significant shrinkage, leading to lot of volume changes, and because of this you have many of the problems like the distress in foundations, then loss of contact, many other things. Marshy and soft soils are another classic feature in many of the soft soils in India, like all along coastal areas in India, you have these marshy deposits and soft soils where the shear strength is so low that you can't even walk, and you are expected to construct a nice port structure there. So, when the soft soil is so poor, it is very difficult to construct anything because the bearing capacity is very low, shear strength is so low, and consolidation settlements are going to be very high, permeability is very low, and these are all very peculiar. So, this needs to be improved. Another case, what is called karst deposits. Actually, in some natural formations, there are some soils where there is a formation of holes like sinkholes, like we call them formation of sinkholes. Like we do not know how it forms, but when the water when there is some loss of when there is a contact of soil with water, all that soil is lost and suddenly you find a cavity. So, this is a very big risk. So, you need to fill up those voids or the gaps and then see that the bearing capacity of the soil is there to the extent that we need them, and also settlements are minimum and all that. So, you have see this the general applicability of the ground improvement techniques is that we should have good shear strength, less settlements, and also permeability that will not create lot of problems like pore pressures or seepage and all that. So, we need to do a lot of engineering analysis here, and many of these techniques, particularly the ground improvement techniques, have very wide application, because the objective is that when infrastructure is growing, people should reach out to smallest villages near very, like say for example, you have in Kerala small villages in maybe 100 people, 100 numbers of in a village, but then you need to construct a road which goes through a lot of soft soil deposits, or it could be a place in Andhra Pradesh where the soil is totally expansive, or there could be some waste materials that you would like to construct a multi-story apartment in a building in a city, and then you have liquefiable deposits in the whole of Gujarat, particularly in the Kutch area. Lot of liquefiable soils are there, and we know that particularly in the earthquake of 2001, many dams, buildings, roads have caved in simply because of this liquefaction problems. So, definitely all these ground improvement techniques have very wide applications, and economy of course is the key, because there is no solution here in some places. Maybe in some cases, maybe instead of going for a shallow foundation, one can go for pile foundation, which is again expensive, but in such cases one can go for simple foundations where you have good cost economies achieved with a proper design. I would like to classify the ground modification techniques or improvement techniques in different ways. One is called mechanical modification, in which, say for example, by compacting the soil, you can increase the density of the material, like you can put some rollers in the field and then see that compaction is achieved. This is called mechanical modification. Then the second thing is hydraulic modification, in which we know that the shear strength of the soil is low when the water content is high. So, you try to remove some amount of water, and we are by preloading or by increasing the drainage by prefabricated vertical drains. We have some prefabricated vertical drains that we will discuss. So, we try to remove the water from the soil and also see that it is consolidated to a very high pressure, so that the existing pressure or the pressure that you are going to place later on it will be very minimum, with the result that it helps the purpose. So, this is called hydraulic modification. Then we have another category called physical and chemical modification, in which for example, the soil is poor. I just mentioned the case of an expansive soil, like the liquid limit of the expansive soil is 100% and the shrinkage limit is 10%. So, if I add some sand in the expansive soil, what happens? The liquid limit of the sand will come down, say for example 60%, and the shrinkage limit will increase to 20%. So, what happened is, in the first case, the range of water contents is some 100 minus 10, means 90% is a range of water contents, and then it has lot of it leads to lot of settlements, because that is a tendency of the soil to undergo lot of volume change, volume changes because of water content variations. Now, by adding some sand, like in a physical means, by physical means, What you did was that the water content variations are brought down from the range is from 60 to 20, which means about 40%. From 90% to 40% you reduce the range of water contents, which means that you are able to achieve some sort of stability in some form using physical means. The same thing can be obtained in the case of expanse soil using, say for example, lime. Lime is a classical technique in stabilization of expansive soils. So, you add lime and then it reacts and then it forms cementation bonds and many other things, with the result that even chemically also the same process can be obtained. So, this is what we meant by physical and chemical modifications. And we have another one very important one, modification by inclusion and confinement. Inclusion means the reinforced soil technique. So, for example, you put some we know we are used to reinforced concrete where steel is used to take care of the tensile strains. Similarly, in the case of soils also we put the reinforcement whether in the form of a geogrids or a steel grids or geomembranes. There are so many materials here, one can put them in the form of a reinforcement in soil, and which we call it as reinforced earth or reinforced soil. And the advantage would be that whatever is the load that is on the soil, now it is taken care of by the friction between the soil and reinforcement. We have introduced some sort of reinforcement in the soil, and because if you apply load, what happens is that the load gets transferred to reinforcement and soil, and then there is a friction between the soil and reinforcement. Because of this friction between the soil and reinforcement, the load, that particular component will help in taking the extra additional load. The other important point is the confinement effect. Actually, for example, sands do not have any confinement effect, in the sense you have it does not have any cohesion. We know that sand has negligible cohesion, right, and friction angle is, say for example 30 degrees, and I want to increase the cohesion in sand. I can use this reinforcement or what you call geocells, we will see them, and one can improve the ground using this inclusions or confinement effects, either in the form of a reinforcement like geogrids or using this confinement using geocells. So, this is another important aspect, and one can use many of these combinations. In fact, I have been working on many of these projects where we are able to use combinations as well to just improve the soil and get the desired benefit, like what exactly we want is what we can get, that is the beauty here. So, what you saw just earlier was some sort of classification based on the methodology that we do, but in practice there are many things. You can see that you can say that I can call it ground reinforcement, ground improvement, ground treatment, like it is just the terminology that we are using here, because all the three things are essentially we are trying to improve the ground or its properties, and we are trying to be very specific here when we say ground reinforcement, because the reinforcement action will be very dominating here. Say for example, if I say stone columns, this stone columns is a technique that is used in the case of soft soils. Say for example, in many of the coastal areas in India, whether it is Vizag port or Kandla port or Cochin port, you use this stone columns. It is just what happens is that normally you apply some load. In the case of soft soil, the load is so much, the load cannot be taken care, but if you have similar to piles, you have stone columns made of matrix of stones and aggregates, they will take the load. So, it is a sort of a reinforcing the ground, that is the reason we call it reinforcement. Then we have what is called soil nailing. Actually, we see that many projects we have been doing is this technique has been used, particularly in the case of excavations and all, where there is a tendency for the soils to slip, we use soil nailing. Then micropiling is another technique, where if there is a stability improvement required, instead of piles we use micropiles which can be easily driven into the ground. both soil nails can be driven or inserted into the ground, and micropiles also can be simply inserted into the ground. And the what happens is that when the stone column or soil nailing or micropiling, they are all reinforcement techniques, they intersect the failure surface. The moment they intersect the failure surface, then what happens, there is a shear strength availability along the at the point where this material is available. So, that deflects the failure surface. So, when the failure surface is deflected, the shear strength is going to be, the failure surface will be much, it will have a higher factors of safety. So, we will see some of them. Anyhow, these jet grouting is a similar thing, where grouting is, you are trying to put a stronger material into the system instead of the weaker material. Then we have another terminology called ground anchors. Ground anchors, where you, particularly in the case of excavations and all, I will take you to some construction projects soon, where anchoring is done so that the retaining walls are stable or the excavations do not collapse using ground anchors. We use anchoring mechanism here, like that is a very helpful thing. Then geosynthetics is something that people have been using very to the maximum extent, and there is no substitute to this, that say for example, we are only used to, in a civil engineering sense, we are used to concrete, steel and soil, and then so all these things, if they have any problem, like say for example, you have additional dimension here nowadays with say if there, see even in RCC people have been using geosynthetics, even in hydraulic problems people have been using geosynthetics. So, these geosynthetics have wide applications, and they have been a significant component in ground improvement or ground reinforcement techniques. Then fibers. Fibers is something that, see any of the fibers like coir fibers, steel fibers, we are used to fiber reinforced concrete, why not fiber reinforced soil? In fact, I will show you some examples today how fibers can improve. Then in some places called lime columns, instead of the stone columns, say for example, soil is very soft, so let us put stone columns there, but if the soil is expansive, let us put lime columns, as simple as that. So, this vibro concrete column is another variant of this same thing, where you can get shear strength improvement based on what you need. Then mechanically stabilized earth or reinforced earth wall. Actually, this reinforced earth walls is a standard technique that we have been nowadays, all the flyovers are constructed with this reinforced earth technique. That is called mechanically stabilized earth. Mechanically means you are using the reinforcement there, because it is mechanical, because of the mechanics of interaction of the soil and the reinforcement, the stabilization of the earth is taking place. So, by introducing the reinforcement, we are having a reinforced earth walls rather than gravity walls or the other types of walls like counterfort walls and all that. Now, even biotechnical stabilization, in fact, the slopes are getting eroded. So, what do? We just use some grass onto the erosion the slopes which have erosion, and then what happens, the slopes the profile will not get eroded. Gully erosion is a classical problem, like because of the influence of water which forms on the slope surfaces, you will see gully erosions. But if you have a sort of a grass and some other enzymes, biotechnical stabilization is possible. This is a very challenging area, people have been working on this nowadays to a large extent. Then that way one can just put under the ground reinforcement some of these topics. Then ground improvement, say for example, one can say that when you do the surface compaction, like we said, we know typical rollers that we have which use for rolling purposes, and then get some maximum dry density, and you normally mix the soil at close to optimum moisture content and allow the rollers to do the compaction. So, this is called surface compaction. Then you have as I just mentioned, you remove water from the soil and then it leads to drainage, and because of the drainage or the expulsion of water, there is an increase of shear strength. So, one way of putting that removal of water is by putting lot of load, like what is called surcharge or a preload. In fact, we call it a preload. You will be knowing the concept of pre-consolidation pressure. Pre-consolidation pressure, if you have, definitely the soils will have below the pre-consolidation pressure, the soils will have less settlement. That is a standard thing. So, we try to apply a very high surcharge such that the existing load will be less than the so that the existing load is less than the surcharge, and with the result that whatever settlements of the strength you want, it is there. In some cases, in clays, sometimes we use electroosmosis. The electroosmosis you must have heard in basic geomechanics classes, where since clay particles are negatively charged, you have to remove the if you want to really remove the water, the electroosmosis is one thing that can be effectively used, because the water removal is sometimes you have two types of water. One is called absorbed water, and then in the pore water there is some water, and then there is a water that is adsorbed to the clay surfaces. So, if you want to handle them in a proper way together, electroosmosis combined with drainage is an excellent option. Then we have what is called compaction grouting. Compaction grouting is another technique that we use in many of the cases. Then blasting. In fact, there are, say for example, we see that the soil is liquefiable. So, how do you see that the liquefaction tendency is reduced? Because you just we create blasts into the ground. So, the thing is, I have seen some cases, in fact, you place mine, when you want to break rocks, you do blasting, right. Similar to that, you introduce some charges into the liquefiable deposits and then blast them. What happens? Because of the energy that is there, the whole soil gets consolidated or compacted in about very short time. So, blasting is another technique people have used. In fact, in liquefaction problems, this is one of the techniques used, experimented actually a great deal, because it is a very useful technique and simple to use. Then dynamic compaction is another thing. So, dynamic compaction, there is a difference between, there is called what is called surface compaction and then the dynamic compaction. Here in the surface compaction, what you are doing is we are putting rollers there, and then in the dynamic compaction you are trying to put some tamping from a high like 10 to 15 meters high. You just put lot of weights onto the ground, you dynamically compact the whole soil, and because of the dynamic compaction under a charged weight, there is a possibility that pore pressures are generated already and consolidation occurs. So, once it is consolidation, everything is complete, we can say that the ground is stabilized or improved, then it can be used. Then you have some more sets called ground treatment, like you try to say use a term called treatment, essentially because you add something. Here we treat the soil by using some cement or lime admixtures. Say for example, calcium hydroxide, calcium oxide, many of these materials can be added. Fly ash, if it is available, say for example, the clay has a very high water content, and if you add fly ash, it definitely decreases its liquid limit or the high water content, high water holding capacity. Dewatering is another one. So, in fact, heating and freezing. In fact, the Leaning Tower of Pisa, you will be knowing that the freezing technique was used, because it was tilting, and then they felt that before they start any other new techniques, they wanted to really they use this freezing technique as well in the stabilization of Leaning Tower of Pisa. Then vitrification. Vitrification is nothing but making some material like a gas like material, like this is also very popular, because suppose there is a contaminated soil area, and you do not want that the soil water should go through that material, or that influence of that contaminated soil should be there under the nearby fields or areas. So, you totally solidify or vitrify in the form of a glass. That we will see some example. In fact, there are one or two case studies in abroad where vitrification is also done, because the moment, say for example, there is a site next to the factory, and the factory released lot of hazardous materials, and now that area has to be reused. So, you need to, they have done this sort of vitrification in some cases. Okay. So, now I would like to draw your attention to what are the factors that influence the selection of ground improvement technique. You have seen in the previous slide that there are many techniques that you have for ground improvement, many techniques like not less than 15 to 20, but then you need to decide what exactly we want. So, now we should understand what are the factors that influence the selection of ground improvement technique. It is very important, because this is for the same thing you may have some 3 or 4 techniques for the same say for example, you want a bearing capacity improvement. Bearing capacity improvement can be obtained by many means, like one can use stone columns, one can use reinforced earth, one can use cement slurry injection, one can use addition of fly ash, all that. So, the factors affecting the selection of improvement are very important. So, we should look at what is the type and degree of improvement required. Are you looking at bearing capacity improvement? Are you only looking at settlement reduction, or are you looking at permeability enhancement? Say for example, you would like to see that the permeability is to be increased, so that there is a good drainage. Is it the what you want, or you do not want the permeability increase at all? Then do you want in long term or short term? Say for example, do you want a particular improvement technique in long term or short term? Then liquefaction resistance. So, you need to define what is your main purpose. Say actually many of these techniques will result in many things, like one technique may result, say for example, addition of lime. Addition of lime will increase strength, reduce the settlements and increase permeability, whereas some other additive if you add, it may even decrease permeability also. It may help in increase of strength, increase of the reduction of settlements, but it may reduce the permeability. So, one should look for what exactly you want. You have to pick up the primary mechanism of improvement and also understand what you need exactly. So, what is long term, what is short term? This is another important point, because a soil is getting consolidated, right. We know that. Say for example, I have seen in many places where you need improvement only for 1 year. So, that is short term. Say for example, you start loading on a soft soil. Say for example, you are constructing a soft soil area, a highway embankment 3 meters or 4 meters height with sand and all that you are dumping. The rate of dumping will be so much high that the soft soil area, because of its low permeability, cannot take. So, what we do is that only during that 1 year time, since you are loading and constructing that embankment in 1 year, you want improvement. After that, once you construct the embankment and traffic comes and it is open to traffic, then that is a different story. So, we have what is called short term improvements and long term. Long term means like they will have to be continuously monitored also, in the sense that particularly they have long term has a its life period, like for example 50 years or 100 years. Then liquefaction resistance. So, how does liquefaction resistance can be understood, like by using this technique. So, one should really look at some of these issues in a careful way and decide on the type, what is the type or the degree of improvement required, because the other one important is normally the bearing capacity improvement is explained in terms of the bearing capacity factor. For example, in one case the bearing capacity of the soil is only 10 ton per meter square, 10 ton per meter square then you would like to make it to 30 ton per meter square. So, 30 by 10 is called bearing capacity ratio. So, I can use this, I know exactly what I need, like I need 30 ton per meter square for that area. So, I will get this, I will design this in a proper way such that I will get that 30 or 35 and even conduct a plate load test to see that I get the same thing, because you have to finally confirm to the people that you got this number like 30 ton per meter square, otherwise the technique may not stand at all. You are essentially assume that you are a client or a contract, you are say for example, you are representing the government of India port trust authorities, so some of you may be chief engineer soon, and you may just say that I am the chief engineer of this project and I would like to see that the bearing capacity of the soil is improved to say 30 ton per meter square from 10 ton per meter square. So, that can be done. Actually, the settlement is also same thing, permeability, many of these things you can say, for example, permeability enhancement, initially it may be 10 to the power of minus 7 centimeter per second, I would like to just increase it to minus 5 centimeter per second. How do you do that? So, you should do some experiments in the laboratory, also in the field, and to see that these effects are obtained. Then the type of soil and geological structure, seepage conditions, this is a very big variable in trying to decide about what type of ground improvement techniques are required. As I just saw, we saw what type of clay it is there, what type of sand, what type of foundation. Say for example, depending on the type of clay, say for example, is it a soft soil area or is it an expansive soil area, or it has very loose sand. So, the techniques are different. Say for example, if it is a loose sand, you may use stone columns like that. So, actually say for example, you want foundation, it also depends on the type of foundation you want. Say for example, you are looking at pile foundations as one alternative in the original sense, but then you need to really, because the cost of piling is so much high in India in many places, they wanted to reduce the cost of foundation. So, what should be done? Instead of going for pile foundations, one can provide only a simple it can be in a raft foundation or isolated footings, so that you can get this you can place this both raft foundations or isolated footings on the improved ground. The pile foundations will be, you will be placing them on the original ground, and then you have to compare with the cost of foundations when you place them on the improved ground using ground improvement techniques, and include the cost of ground improvement also. Actually, in many projects what happened is that there is a significant effect of this ground improvement techniques in terms of the cost, sustainability, and ease with which it can be done, confidence to profession. There are many issues here. Then the role of pore water pressure and seepage. I just mentioned about the permeability enhancement or decrease. If you just want higher pore pressures to be mobilized or dissipated, in fact, if the water can go faster, the drainage is better. So, when the drainage is better, what happens? Pore pressures are less. So, you provide a means of proper drainage. And seepage also, like say for example, if the seepage is, there is lot of seepage, what happens? The soil particles come out. So, that is another problem. So, presence of a difficult geological condition, I just mentioned about a few minutes back, that presence of karst deposits, like which have tendency to form holes, is another risky thing. So, the type of soil, geological structure, seepage conditions influence the ground improvement technique choice. Cost, equipment and specifications. This is a very important thing. Size of the project. Are you trying to go for simple multi-storied building, or you want for a bigger colony? Because ground improvement techniques, it is all done by a number of contractors. Many people would do that. If it is a small project, they may not come. So, you may have a very nice idea about a ground improvement technique, but then if the size of the project is too small that the contractor is not ready to come, then it is useless. Then availability of the equipment. In fact, this is a very important thing. Many of the ground improvement techniques need some sort of specialized equipment. Say for example, if you are making stone columns, you have to have some sort of equipment which can make holes into the ground, then compact them into the in situ, then like that. So, you need some good equipment, and the contractor will not come if the size of the project is too small. Say for example, if you have a small house of 100 by 100 or feet and area, if you want a ground improvement technique for that, they may not be ready to come, because the mobilization costs are so high that he may not be ready to come for that, or otherwise the technique will be too high for you also. Then transportation costs as another important variable. Many of the ground improvement techniques need specialized contractors. It is not easy because in soil mechanics or geotechnical engineering, you need to have a lot of experience in soils, otherwise the project is it will be in a serious problem. Okay. Then say for example, I must tell you many examples in our own case. Say soil nailing, you do not have good contractors. Micropiling, you do not have good contractors, but if you have good contractors, they are very expensive. So, the owner is always worried about should I go for a contractor who can give me at a low price and I am not sure about the quality, or go for a good contractor where we are assured of the quality, but at the same time he is expensive. This is a very big problem in many of the projects. Then specification of the work. Okay, we may understand fundamentals and design, everything is perfect, analysis is also perfect, but when you want to do the work, you have to you should be in specifications like Government of India specifications, like what should be done and in what form. You should give them the sequence of work right from the beginning, cleaning of the ground to complete erection of the ground, the complete work, right from making you have to make initially clean the ground, then bring the equipment, then make some holes at a specified spacing. There are so many issues there, it is not easy. So, people should have the specifications properly written. All the consultants, all the engineers should understand the specifications, and in some cases what happens, many of the ground improvement techniques are well developed in some countries, but in some other countries if you want to use them, they are not available, because in that country the specifications may not be accepted. So, that is a big problem. So, for example, in Indian conditions, we do not have too many specifications for ground improvement techniques. We just have one for stone columns and geosynthetics a bit, but it is not complete. So, this is a big problem when the contractor wants to use some of these techniques. Then guidance documents, say specification of the work is one thing, guidance documents, say for example, when you are trying to use a new technique, the contractor should know completely, the owner should know completely, the engineer should know completely, even all parties. In fact, in any of the construction projects, there are at least 4 people. One is a owner, say either it can be a government, the next one is a designer, then a contractor, then you may also have some supplier also. In some cases you may have a supplier, you may also have somebody like a quality control supervisor. There are many people that are there in this business, and they should know, if otherwise all should understand the principles of the ground improvement techniques and also how it should work in a given situation and discuss thoroughly. So, the guidance documents will help you a great deal. Otherwise, there will be a lot of conflicts between the owner and the contractor and the supplier and the actual installer. It leads to project delays, which is again a problem. So, one needs to have good guidance documents. Then the construction time. So, you should be very clear about this construction time, because the ground improvement techniques actually were using to save some time. Say for example, you would like to construct a project in 6 months or 1 year. Normally we will see that there are different ground improvement techniques. Normal consolidation of the soil, it says that say for example, it takes 9 years for 90 or 90% of consolidation to occur. You do not want 8 to 9 years to wait, you want everything in 1 year. So, you can back calculate and introduce the drainage in a proper way. So, within 1 year, which is supposed to be a construction time, I can finish consolidation completely rather than 9 years or 8 years time. So, construction time available should be clearly known, and the purpose also should be clearly known. Then use of accelerated construction techniques. In some cases it is possible to use number of techniques to accelerate the whole process. We have done couple of projects on this, where one can do accelerated means of constructing underpasses using box jacking techniques, where certain underpasses were able to be completed within 5 to 6 months time, when the normal time itself is 3 years. I will show you those pictures. Then when you are trying to use a ground improvement technique, you should also understand that, say for example, you have an apartment, and next to that you want to construct another apartment. So, if you start excavation next to the apartment, what happens? That that owner will come and then put he will sue you, because the moment you start excavation, what happens? There will be some cracks in buildings and there will be a problem. So, what happens is that one should understand what are the tolerable levels of loading and deformation. Say for example, you know about the concept of differential settlements and total settlements, right. So, if you just remove some amount of soil next to the ground, what happens? Actually the apartment is standing because of the confinement effect. Now you removed some overburden or about 5 meters, then all the failure planes develop towards the excavation side, and the whole constructed building starts to tilt. That is a very dangerous situation. So, one should use proper ground improvement techniques. I will show you, in fact, in nearby area only they are using micro piles. Micro piles one can use for apartments, where you do not have a there is no problem of deformation at all. Just the there is a 3-storied or 4-storied apartment, next to that there is a vertically they are cutting it, because they have used already some sort of micro piles there. Then, so that way one should know what are the tolerable levels of loading and deformation. Then pore water pressure contamination is something that one should understand, because by our operations we should not contaminate groundwater. In any of the ground improvement projects, suppose you are using lime or you are using something or flash or anything, it should not lead to some difficulties, and people should not put a case against you later. This is one thing. So, these will influence the choice of the ground improvement technique. Next is the durability of the materials. See, for example, there are many materials which can be used in different conditions, both in short term and long term. Like I will show you the coir fibers. Coir fibers or coir geotextiles, there are two types, one is called coir geotextile and a jute geotextile, and even natural regular geosynthetic materials like plastics. The plastics can be used for long term, and whereas coir and jute geotextiles can be used for short term. Then there are some materials which will have corrosion. Say for example, in places like Bombay, because of the sea intrusion and all that, people use they say that no, I do not want to use the steel, I would like to use have a PVC coated materials like that. So, aggressive soil conditions are another important problems, because finally the whatever you are using ground improvement technique, and say for example, you are putting some reinforcement, the reinforcement should be there working for about 30, 40 years or 50 years. If the reinforcement is dissolved because of the aggressive soil conditions or some other problems, or somebody removes it, then it is a serious issue. Okay. Then we have what is called toxicity and corrosivity of the chemical additives. Actually, as I just said, the example of what is called contaminated ground. In many countries, this has been a big problem, and if the soil has lot of toxic chemicals like chromium, mercury and some of them, then it is very difficult. So, sometimes we do not know what type of additives you should use in those adverse chemical environments. So, if you add some chemicals, the problem is that we do not know the chemical reactions, that may lead to lot of problems. So, it is better that one needs to understand the chemistry of the soil, as well as the toxicity and the corrosivity of the additives that we are going to have, so that the problem is not there. I just mentioned about using vitrification of the soils to limit radioactive or hazardous waste. Actually, this is one example, as I just mentioned, remediation of chromium contaminated soil through ex situ vitrification. It is an ASC journal paper, I was just seeing this morning, where they were able to in fact see that the soil is I mean the contaminated soil is stabilized using vitrification. Then there is another classical example. One should understand that toxicity and corrosivity of the chemical additives is also very important in ground improvement techniques, particularly when you are using chemical additives. Another important point that governs the choice of ground improvement technique is reversibility or the irreversibility of the process. Actually, people have been using lime for expansive soil treatment. What we hope here is that the soil will not swell when you add lime, that is our assumption. But you have seen that in particularly when the sulphate is present in the soil, the expansive soil comes back, the nature comes back, like you may, the heave will be more than you expect. Say for example, the percent heave may be 5% in one case or 10%. When the soil is present, and then there is the sulphate soil is present, it is so bad that you have the whatever stabilization you have done becomes useless. In fact, in Texas area, Texas, Arlington and many of the places in US, a lot of roads have got damaged. They initially thought that the Texas area is full of expansive soils, and what happens is that they thought that by treating the soil with lime injection and all that, they thought that they can have this problem rectified. But what they finally observed was that since the soil is has sulphate, heave took place, and the problem it got worsened. Actually, I will show you some of these photos also in a very detailed manner later, because this is a very important thing people have been addressing. In fact, Texas and many other places. Luckily in India we still did not realize whether this has been a problem in some places, but one should find out the sulphate content in the soil and then come out to see if they if this not it is within some acceptable levels of sulphate, then one can go for lime treatment. Otherwise, lime treatment in the presence of sulphate will be very dangerous, and the process is reverse, it gets reversed. You thought you want to reduce expansion, but expansion starts. It is a very risky process. Then is another important component here, reusability of components such as steel, plastics, concrete and many places. Actually, in many of the ground improvement techniques, the beauty is that you should be able to reuse many of the materials. You are using, say for example, geogrids in a project. The geogrids can be reused, and then you can really form some sort of material like this. In fact, this is a geocell road, and this is all plastic plastic water bottles. This is also waste. This can be used in many cases. In fact, I showed you a previous example where the vitrification of the soil was done. In fact, I understand from that paper that now because of the vitrification, all that soil is now such a strong hard material that they have just used it as made it broken into pieces and then used as an aggregate in a pavement. So, one should be able to reuse the components in the ground improvement techniques also. So, this is another important point that we have the reliability of methods of testing, analysis and design, because the actually as I just mentioned, the soil is soft, we say. How do you test a soft whether the soil is soft? You take a vein shear test and do a vein shear testing, and then it will give you some shear strength, or take some undersurface samples, you will get some properties of the soil. And say for example, you are using a cone test or an SPT test, right. So, you should have good methods of testing. Say for example, the bearing the undrained shear strength of the soil, you get it as 5 ton per meter square. So, what is ultimate bearing capacity of the soft soil? 5.14 into Cu. So, 5.14 into Cu. So, if you know Cu, undrained shear strength by 2 will give you the cohesion. So, 5.14 into Cu will give you the ultimate bearing capacity, and you divide by a factor of safety of 3, what do you get? You get allowable bearing capacity, right. So, you have to really estimate these numbers in a proper manner, like the testing methods should be very good. Then proven methods of design and analysis. Actually, what is happening in some places is that they do not design the things properly. They use okay, the soil is same as that soil. I have a sandy soil here, and in that project also they have a sandy soil. They use the particular ground improvement technique. I want to use the same thing here, same spacing here, same length here. That is not correct. That you may, then they will just justify that because soil is same, so I can have the same design. So, that may not be correct. So, one should have a proven methods of analysis and design, because you have to really clearly show that this is the bearing capacity before treatment, this is the improved, this is by means of some analysis and design, you have to come out with a number. Okay, earlier the bearing capacity is 10 ton per meter square. Now, by my method and design, I made it to 30 ton per meter square, and I am using stone columns here for the improvement, and the design of stone columns gives you the length of the stone column, the diameter of the stone column, and the spacing of the stone column. So, one should have a proven method of design which is accepted by codes of practice like Federal Highway or US codes or many of these things, and even analysis should be thorough, otherwise it is a big problem. And empirical approaches should not be used to the extent possible, because as I just mentioned in geotechnical engineering, empirical design, like whatever they use in some place, they try to justify and then come out with simple equations. Say for example, I will tell you the classical example of an SPT. You have an SPT value, and then there is a connection to the phi value. You have a one SPT test result, and you will get one phi value, and that equation that you are using is not specific to that area. It is a equation that is derived out of Japanese practice or an American practice. What you are doing is an SPT test in some place in India, and we do not know whether the same SPT actually, there are so many uncertainties in SPT test, because the height of drop, the weight of the hammer, and there are so many issues. One should be very, very careful. So, one should really use scientific approaches to come out with proper methods of design. I mean they should avoid empirical approaches and also come out with good methods of testing, proven methods of analysis and design. This is very important. And another important point is, see, the thing is, the reliability of methods of testing, why it is important is that, see, if the testing is correct and analysis is correct, you can come out with a proper choice. Even the choice of ground improvement techniques depend on this, because there is I have seen a case wherein say the soil is your grain size distribution itself, it can be misleading. Based on the grain size distributions also, there is a thin margin of very thin margin in choosing these materials. Their efficiency actually, particularly the efficiency of the technique depends on many of these properties of the soils that need to be improved. So, one should do proper testing. Then very important point is feasibility of construction control and performance measurements. See, in the field you may design a ground improvement technique, but how well it is done or executed in the field is very important. And when it is not done, you need to have a lot of controls also, like it is a sequence of control should be there, like you excavate, then put a reinforcement, then compact it. There are so many construction controls. One should have a proper construction control operations, and particularly the ground improvement techniques, their see, soil is so variable that it is very difficult to really say that you have, based on some few test results, you can say that the soil is entire soil is same. So, one should have construction control, because the borehole information may be different from there will be differences in borehole information. So, one should be very careful. So, one needs to have a lot of construction control. I can have a lot of examples on how construction control is very useful. And other important point is performance measurements. You are expecting that like say settlements will come down, so you have to measure them. You have to see, for example, you keep on measuring the settlements, then only you can say that the settlements are not there. You use a ground improvement technique, and if you do not measure and then there is a settlement, then there is a big problem. So one needs to have this. So documents of quality control and performance are required. So for example, compaction control, what type of at what spacing you should take samples, or what type of test, like say for example sand replacement test should be really specified, and then they should be used in lot of ground improvement projects. So this is another point that I think I would like to cover next class. So what we covered so far is that we are able to understand the various problems that one can have in geotechnical engineering, and also the ground improvement techniques that one needs to choose. We have covered varieties of ground improvement techniques, and means at least some introduction to them, and also discussed about various factors that can influence the choice of ground improvement techniques. Thank you.